Now we have Tatiana Gavrilova, professor for St. Petersburg State University, and her topic sounds very futuristic, but this is reality, right here, right now. When AI will come out of the black box and attempt to comprehend, it's not just the next TV series, it's all about the present-day life. Thank you, Roman. Hello, everyone. I really wanted to think about this topic, and I'm really grateful to the previous speakers. Andrei Derivanka has just mentioned it, but I would like to take a different perspective. A few words about me. I work with artificial intelligence for many years. First, I started in St. Petersburg State Polytechnic University. Now, first I started in the Polytechnic University, now in State University. I'm head of AI department. It started in 1888. To Pospelov were the founders of this association. Here's the photo from the first convention, and I was lucky enough to participate in it. Please read more about it if you're interested. We mainly consider AI from an engineering and mathematical point of view, but originally it was interdisciplinary research, and skipping philosophy, psychology, linguistics, anthropology, artificial intelligence and neuroscience would be very strange. So I would like to cover how AI developed and why we are in this double black box situation. First, about the mistranslation into Russian language. Globally, intelligence is an ability to have a way to reason, an intellectual way to reason. But mathematical intelligence is not the same, is not the sum of all the intelligences which we want to model, but everything else is much harder to model compared to the logical and mathematical ones. But we live in a real world and we use the whole scope of intelligence. Intelligence is not just intelligence. We have a wider concept which is called intellect, and intellect includes intelligence. In Russian language, we have at least 9 definitions for intelligence as by intellect. But the definition we use in this routine is only a tenth of what we really would like to model and what common people think about it. When we say artificial intelligence, people have some unnecessary hyper-associations. The founders of the artificial intelligence said that it's an attempt to perform some tasks which are usually considered intelligent. Jean Piaget said that intelligence is what you use when you don't know what to do. Before that, well, obviously, artificial intelligence is not near enough that intelligence. I don't like this left-right brain separation either. It's not that simple. But on average, the functions of the left brain are modeled, but the functions of the right brain are not modeled at all. And the attempts to get into the right hemisphere are very clumsy. It's not by chance that artificial intelligence was developed both in the United States and in Moscow. Moscow, it was even 2 years sooner, during a seminar by Andrei Lyapunov, an academician, at 1954 workshop. And they were ready to start the movement in that area. And the famous Dartmouth College in 1956, where they used this definition, where they coined the artificial intelligence term, is the point of origin. But now we substitute. We use the problems of machine learning instead of artificial intelligence. Take a look at machine learning. It's only a part of the whole machine learning. Neural networks are part of machine learning. Deep learning is part of neural network. and part of neuroscience. As a result, we have definition substitution. So let's not speak about an artificial intelligence globally when we mention deep learning, when we mention only the part of artificial intelligence. Originally, it's separated into two branches. The first one dealt with neuroscience, the one I mentioned just before, everything connected with neural networks, because scientists believed that if we model an intellectual activity and the brain is the only device we have for intellectual activity, we have to model the brain. While the rest of the scientists believed, no, that's wrong. They said that if we want to model a brain, we need algorithms which will give us the same output as human brains. But it doesn't really matter what's the inside. Like an airplane, they fly, they don't have like normal wings like birds do. Doesn't really matter if it flies, it's fine. And here we have this black box approach. First they started with labyrinth, they were followed by logical models, now we have knowledge-based systems, and it goes on. Unfortunately, these two branches do not intersect. They live on their own. Everybody hopes and dreams that they would join together because it's great in knowledge-based or explainable AI, but the situation in data-based neuroscience is not that great. These two branches have a common strategy. In neuroscience, we go upwards, we go bottom top, we try to analyze data, we work on image recognition. In knowledge-based system, we go top down. Neuroscience is very far apart from knowledge-based. If we take a look at the real brain, how they look and how neural networks look like, you can have beautiful algorithms, but nobody really knows the algorithms of the creator. And this function, which sends the impulse through dendrites, nucleus, and axons to the next neuron, nobody really knows the formula, and nobody will see it. Well, thanks to God. Weak or strong AI. Strong AI, which can also be known as artificial general intelligence, and can solve a wide range of problems. Well, we do not have this kind of AI, at least now. AI hype really concerns everybody who is seriously involved in AI development. Right now we have only weak AI, and it can solve only some specific problems. If we take a look at the history of AI, two branches, there were some intersections, but they were living their own separate lives. They had ups and downs, and now we are living on the next up session. Everybody tries to jump on this bandwagon, which goes the right direction, and we have to take into account this hype and go deeper. Speaking about the science, well, on the right, speaking about the black box or the strong artificial intelligence, then we have the engineering of knowledge, which tries to know with knowledge, with consciousness. Obviously, knowledge is very hard to define in itself, but still, now we can create knowledge databases. We have substantial success and results. Previously, they were called expert systems. Now they are recommending systems. They provide prompts, and it's not that bad here, actually. But now, it's all about neuroscience. It's all about formalizing knowledge, but it's alive and it's kicking, because we can see the representation models in simple models for ontology, and now we go to the knowledge graphs. We don't see them, but all the big companies like Microsoft, Google, and Facebook use knowledge graphs, and the big data they have there are stored inside whatever we do every day via the social media. They are not perfect, but they exist and make our life much easier. So we should not forget about this right part of the artificial intelligence. Knowledge graphs now is very important to develop, but they work only on big data. And this is the point in time where we don't have just label big data. They actually work. It's real big data, but it's not just garbage of unconnected data. These are connected into some graphs, semantic graphs, which makes it possible to have a quick search, and you can even see it yourself. If you Google something, it's much more sensible now. I will not go into all the details. You can take a look at the Gartner quadrant for 2020 and see what is there and where is the hype peak. I would like to say that the money poured into artificial intelligence, well, you need some return on investment. Everything labeled with intelligent, we should divide by 2, or maybe even by 10. Well, we say intelligent robots. Boston Dynamics says it's great, they are very intelligent. Now they can stand up when they fall down, or they can dance to the music, but that's not intelligence. This implies to vision problems, machine vision problems. We don't really know how people process visual information, and the algorithms now make mistakes, and these mistakes might be fatal. When we say that artificial intelligence creates something, that they go into arts, but that's not really something new, that's not arts. That's just, they're not really there to recreate Chopin or Mendelssohn. They're not really recreating the great pieces of arts, literature, or poetry, music. There is great success in games, chess and Go, for example. Computer can play these games, but they are very specific, they are very professional, so to say. The Deep Blue played versus Kasparov, didn't really try to play versus Karpov. AlphaGo is, well, my husband likes to play Go. Lee Si-dun said that the program was just storm, it's very dumb, it learned for 36 million games. If a person would learn on this data set, he would or she would win. Classical natural language processing is getting better, but they cannot do some simple things. If you try to translate some simple language, some simple phrase into another language, then there might be some problems with cases and different genders, because not a single program can understand all the nuances in the cases between different languages. We have multi-parameter cases. We have some example here. All the programs failed Turing test. I tried to talk to the Princeton program. They said that they passed Turing test by 30%, but that was a complete fake. As of now, we have a lot of success, but we also have many problems connected with the fact that artificial intelligence takes only the upper part of the problems. We cannot speak about cultural differences, which we take into account when living our normal lives. There are some fatal mistakes, as in the case of self-driving cars. It was already mentioned that we have bias based on bad samples. We can teach machines something really, really bad. Robots which provide chatbots or maybe audio bots will fail. Microsoft chatbot started to behave bad and was closed off in 60 minutes. And here's a funny moment. A special camera, AI camera, missed the ball and the bold shine of a referee, and they tracked the head of a referee instead of the ball because, well, they look similar. And to conclude, well, I will skip some slides, and I would say let's be very intelligent about the artificial intelligence and do not expect much more than it can do. For now, it's black box, and thank you for your attention. And now, I would like to say that even though I had a pessimistic approach, I still believe in science and that it cannot be stopped. I think that artificial intelligence is for the future if we will not have any con man there and incompetent people there. Thank you for your attention, and over to you.
Thank you, Tatiana. It was Tatiana Gavrilova, professor from the State University, and I personally like to thank all the participants for these vivid and lively examples.